Yep, good afternoon, everybody. Those of you who are here a little bit early, welcome to our webinar on the Promag W 0DN, the world's first flow meter for completely unrestricted flow measurement. You would have seen this screen shared probably about 10-15 minutes ago, and on the top right corner, you'll see there's a QR code. We are going to be running some interactive polls and questionnaires during this webinar. So if you can just, the easiest way I find of doing it is just to scan that QR code onto your phone. There'll be a button to click on, and that will take you to a website called Mentimeter, and this is where we'll be running the poll from. Alternatively, if you want to run this on your computer, that's fine. Just enter www.menti.com and then enter the code 279849. That's 279849. All will become very, very clear in a few slides' time when we start to run some of those polls. So we're just on 3 p.m. So let's get going. So firstly, welcome. This is the second Promag W 0DN external webinar we've run. We run the first one, I think, towards the end of March, so quite a few months ago now. We had a really good attendance rate there and plenty of questions, and we thought we'd advertise and run another webinar on the Promag W 0DN. Since then, we've had quite a few installations, not only in Australia, but also worldwide, and we have some really nice application examples to show you in this webinar, as well as an explanation of how the flow meter works and some use cases and things like that. So for those of you who haven't joined GoToWebinar before, or at least one of Endress+Hauser's ones, you should see this screen in front of you. So at the top will be a webcam, and there will be myself and then my colleagues Taylor and Gustavo, who are in Sydney at the moment. Below that, you'll see the presentation screen. On the right-hand side, you'll see a dashboard. That's where you can ask any questions you want throughout the webinar. Feel free to ask them on any slide you want. We'll get to them at the end. We've got 45 minutes today, so we should have a good 10-15 minutes at the end for questions. You'll also see a section to download the handout. So in there should be a PDF file with these presentation slides. So click on that button and you'll instantly download those slides. If you don't manage to do it today, we'll send you an email probably around midday tomorrow with a recording for this webinar, as well as the slide pack as well. So a couple of chances to download those. Now, a brief introduction. So my name's Luke. I've been with Endress+Hauser for 3.5 years now. My first 2.5 years were spent in sales for the water and wastewater industry in Queensland, which is where I'm based at the moment in Brisbane, and then down in Sydney. And on the other webcam, you should see Taylor and Gustavo. So Taylor, I'll hand over to you to do a quick introduction.
Thanks very much, Luke. Good afternoon, everyone. So my name is Taylor McCurdish. I'm the industry manager for mining and oil and gas as well, based in Sydney. I've been with Endress+Hauser for about 3 years now, and previously I was with a large mining company as a process engineer and as an improvement optimization engineer as well. That's a bit about me. I'll hand over to Gus.
All right, thanks, Taylor. Hello, everyone. My name is Gustavo Queiroz, or simply Gus, and I'm the industry manager responsible for the food and beverage market. And I've been working with Endress+Hauser for nearly 10 years right now, most of this time in Brazil, where I worked with services and then product management before I moved to Australia. I guess that's a very brief introduction about ourselves, and now we can hand it back over to Luke. So.
Perfect. Cheers, Taylor. Cheers, Gus. We'll see you guys, I think, when we get to the application examples in a few slides' time. So let's get over to the agenda. So at the start, I'm just going to give you a very brief introduction of the evolution of Endress+Hauser electromagnetic flow meters way back when we started producing them in '77 to where we are today with the 0DN. Then we're going to look in depth at the 0DN, how does it work, options available. Then we'll go into application examples across various industries where we'll see Taylor and Gustavo again. Then we have a few slides on heartbeat, self-verification and diagnostics. Then I'll introduce you to some online tools that are available, and then we'll have some time at the end for questions. So, as I mentioned before, Endress+Hauser have been producing flow meters since 1977. We've produced way over 2 million now since we first started making them, way back from the first introduction in 1977 to, hang on, I'm just going to put my pointer on 1 second. To the new Proline series in 91, to the second Proline series in 99, to where we are today with the Proline 100, 200, 300, 400 and 500 series transmitters, and then to where we are at the start of January, or at the end of January, sorry, where the Promag 0DN is. So we've got very, very good competence in flow meter production. We've got production facilities all over the world. Many of the flow meters produced for the Australian market come from either France or India. We also have a huge calibration facility in China, as well as production facilities in Switzerland, Brazil and USA. So we're really at the top of our game when it comes to flow meters. And now with the 0DN, we've really covered our portfolio too. So here it is, the Promag W 0DN. So this, in short, is the first and the only electromagnetic flow meter combining 0 inlet and outlet runs with a full bore design, completely independent of the flow profile. So you would have seen from ourselves and some other suppliers too that they do advertise a 0DN flow meter with a constricted bore. This is the only full bore 0DN flow meter. So that means there's 0 pressure drop, which means a reduction in pumping costs, and also plenty more application examples for this flow meter. So it's a pretty cool, innovative solution from Endress+Hauser, and hopefully this presentation will show you how it works and some real application examples for your industry. So no restriction with a 0DN. So it's the only flow meter with no prior restriction, no pressure loss, and completely independent of the flow profile. Now that means that we can install the flow meter after bends, T-fittings, insertion devices. The applications are nearly endless for this flow meter. Now, many of you mechanical engineers, instrumentation engineers, process engineers will know for a typical electromagnetic flow meter, you'll need at least 5 diameters, so pipe diameters upstream, and 2 diameters downstream of the flow meter in order to produce an accurate result. This is now no longer an issue with the 0DN. You can install it in pretty much any application you like, and I'm going to go through some application examples in a second. So really, it's a big game changer in the market. It's got a very innovative design with multiple pairs of electrodes, which I'll go on to show you in a couple of slides too. So this is the only flow meter to produce an accurate result independent of the flow profile. On the right-hand side, you'll see quite a nice simulation diagram. So you'll see those lines represent different velocities. So the dark red color being the high velocity and the green color being the low velocity. Flow meters like to be in this region here. They like to have a nice clean velocity profile in order to give you that accurate reproducible result. When you hit a bend or a T-junction or an insertion type device, the velocity profile is going to change. It's going to look something like this. If we were to put a standard flow meter here, you get an awful result. You get inaccuracies 5, 10%. With a 0DN, we can put that flow meter in this location here and have no difference in the accuracy. So still maintaining and guaranteeing a 0.5% error, no matter the installation. So here are the cornerstones of the design, which I'll go through in a little bit more detail. So flanges, we can do welded lap joint flanges. For example, in Australia, at least in the water and wastewater market, which I manage for Endress+Hauser Australia, we can do table D flanges, table E, table F flanges, whatever you like, we can produce. And same goes for the mining market, as well as the food and beverage market as well. Nominal diameters with this brand new calibration facility, which we have over in China, we can now go up to 3 meters. So enormous line sizes with the 0DN flow meter. Not a huge amount of application cases in Australia, maybe a couple of hydroelectric plants, but still we can go way up to those diameters. Liners wise, we have the standard liners for water and wastewater, and so being polyurethane and hard rubber. We do have PTFE liner. If you do have particularly corrosive applications, we can also give you that liner as well. Transmitters, it covers all of our Proline 3 series of transmitters, so the 300, 400, which many of you are familiar with, and the 500 series of transmitters. These all have wireless LAN and remote connectivity and heartbeat verification capability, which I'll go on to explain towards the end of the presentation. As you know, suitable for inlet 0dN inlet and outlet runs as well. And with that, we can get a guaranteed maximum error of 0.5% of the reading as well. Excuse me. So one of the first questions we get asked is, how does it work? So how are you able to install this in 0dN applications and still maintain that guaranteed accuracy of 0.5%? To put it simply, we've added another pair of electrodes. So from 1 inch up to DN65, we have 2 pairs of electrodes. So 4 electrodes in total, whereas your standard flow meter would only have 2 electrodes or 1 pair of electrodes. For anything above DN65, we had 3 pairs of electrodes. And these are situated in an area that gives you the highest accuracy. So this has come from years and years of research. We haven't just plunked these electrodes here and we got the result we desired. We tried all sorts of positions, and this is where they've settled on. And this diagram here is quite a nice, neat explanation of exactly how it works. So if you can imagine you've ever had an ECG on an electrocardiogram, they situate these pads all around your body to pick up that best signal so you can see your heart rhythm or your heart rate. So the key is to finding that optimal pickup position. That's why they use a number of pads. A similar theory can apply to the 0dN flow meter. So with your standard flow meter, we've got this 1 pair of electrodes around the center of the pipe. What we've done is put these additional pairs of electrodes. So you can see 1 here and another pair there. So now we have 3 pairs of electrodes that can handle that changing velocity profile. There's also some innovative signal processing happening in the background to give you that guaranteed 0.5% accuracy. If we compare it to a standard flow meter where we've only got that 1 pair of electrodes, they can't really handle that velocity profile changes, and that's where you end up with that error. So typical pain points, what we find is the most common application for water and wastewater plants or sewage pump stations or water pump stations is installation downstream of the bends. So typically this would be a pretty horrible installation for a standard flow meter, but with the 0dN, we can easily cover that. So straight after one bend, straight before another bend, we can use the 0dN flow meter. Similarly, for insertion type devices, this is also very important and often neglected. If, say, we had an insertion type thermal flow switch upstream of the flow meter, that's going to cause some changes in the velocity profile and therefore some inaccuracy of your flow meter. With a 0dN, we don't have to worry about that anymore. We can put this insertion type thermal device or another device as close as we want to that flow meter, and we're still going to get the accurate result. Some more applications. So downstream of build-up in pipe, this could be a very typical application in, say, for example, of the raw water side of a water treatment plant. Over time, that pipe's going to fill up. Particularly, this is an old line. There is going to be some build-up in there, which is going to change the velocity profile. With the 0dN, we don't have to worry about that anymore. We can put it straight after that build-up, and you're still going to get a good result. Another common installation is downstream of nominal diameter differences. So you may have one pipe schedule here and another pipe schedule to the right. That change in diameter there is going to change your velocity profile. With a 0dN, we don't have to worry about that at all. So very versatile for those applications. Other common applications downstream with T-fittings, again, very common in pump stations and in treatment plants. This one at the bottom, very common in dewatering skids for the mining industry. So downstream where you can have some misaligned ceilings, again with a 0dN, we can just put that flow meter right there and it's not going to have any issues in reading that flow. So another question we'll be asked is, we'll prove it. Well, we have what we consider some of the best calibration facilities in the world over in all of our production facilities in France and Switzerland, in India and China and the US, but we've also taken this flow meter to a third-party institute located in Scotland in the UK, and we've run some tests there. So here you'll see a DN250 flow meter installed directly after the bend. I remember I showed you that image before. Well, here it is in real life, and here are the results. So on the x-axis, we've got the flow velocity. On the y-axis, we've got the percentage error. On the dashed lines here, this is the expectation for a flow meter that is within 0.5% error. And the blue dots here, or the blue squares, sorry, is where the 0 to the end sits. So we are well within this bound for 0.5% accuracy. So really pleasing results there. And after this presentation, I can send you that calibration certificate too. Another one done at the same facility. So we've installed this flow meter straight after an orifice plate here. This could be quite common again on the raw water line of a water treatment plant where, say, 20 years ago, they may have installed an orifice plate and now they want to change to an electromagnetic flow meter. So typically we couldn't do this. We couldn't bolt it on straight after that orifice plate. There's going to be all sorts of velocity profile changes there. With a 0 to the N, at different angles of this orifice plate, for every application, we're still well within this 0.5% dash line as well. Again, let's have a look at the install before and after bends. Typically a horrible application for a standard flow meter. In every kind of install here, whether it's here, it's up here, or down here, we're still well within those accuracy limits. So some really, really good results there. Another point to make with the 0 to the N, it's available with all different types of IP ratings. So whether that be standard IP67 flow meter, so an above ground installation, of course we can do that. Also, if there was any flooded applications or applications which may be subject to flooding, for example, in a flow meter pit or in a valve pit, we can do that as well with IP68 protection. This will be a fully welded sensor design, so suitable for submersion permanently for 3 meters. And then also with this additional grey coating option, we can even put these in corrosive applications too. So we cover all sorts of applications with the 0 to the N, both with the design of the sensor itself and also with the IP ratings. The third question we get asked is, okay, we've got all these fantastic solutions here for the 0 to the N and the heartbeat and the verification and IP ratings, but how much does it cost? The flow meter is only 5% above the standard flow meter. Say you ordered a DM150 flow meter with all the standard options, let's say table D flanges for the Australian market, and now you wanted a 0 to the N, it's only 5% above that cost. So when you consider all of your savings in terms of piping requirements, concrete pads, everything I'm going to go over in the next few slides, it's a pretty attractive price for this flow meter as well. Right, now we're going to go on to Mentimeter. So I mentioned at the start of the presentation to scan that QR code on your phone or to go to menti.com and type in that code. And the first question I'm going to ask after those initial slides is, which installation feature of the Promag W 0 to the N is the most important for your industry? So I'm just going to open this and switch the screen. 1 second. Okay, so you should see the Mentimeter screen, and here comes the question now. Okay, so those are your options down the bottom. I went through each of those before. If you can, select which option is most important for your industry. So that be installation downstream of bends, downstream of nominal pipe diameter differences, T-fittings, misaligned ceilings, or build up within the pipe. And then we're going to have a look at those answers in a second. Okay, a few of you have answered. Let's get 15, 20 more seconds, and then we'll go over those answers. So you can see that most of you are selecting downstream or upstream of bends, which is the first application I showed you, which is the most common one. Downstream of build-up and pipe insulate, interesting to see those answers too. Okay, perfect. Okay, so most of you selected downstream and upstream of bends, which is kind of what I expected. If we had a lot of mining customers in here, I may have expected this fourth one along here, so insulation downstream of the misaligned ceilings. But yeah, we're sticking with the upstream and downstream of bends, which is what I expected as well. So keep that screen open on your phone because we are going to have another question towards the end of this presentation as well. I'm just going to switch back to the main screen. Okay, which we should see now. Right, now we're going to go through some real application examples. So I did mention at the start, but we ran this webinar towards the end of March, and since that point we've had some really nice installations all over the world, in particular here in Australia, and also some nice ones in the US. So I'm going to show you some real examples as well as some use cases as well. So in water and wastewater, you can see there's all different types of applications here, whether it be district cooling, desalination plants, for example, at the water intake, wastewater treatment, so the inlet and outlet primary treatments, or MBRs, for example, water supply, so your water pump stations, your sewage pump stations. We've seen plenty of real examples in that field, and also skid building as well, which Gustavo is going to touch on in a few slides' time. So here's a picture I took at a customer's site in the north of Queensland. So this is an MBBR outlet. On each of these, they've got 6 DN450 flow meters. So we need roughly 2 meters upstream and 1 meter downstream in order to comply with the 5DN and 2DN installation requirements. So that's exactly what they've done. This is a standard flow meter. Now imagine if we can reduce those to, say, having 1 bend here and 1 bend here. All of a sudden, we've got huge savings in the pipeworks, in the support requirements, in the concrete pad as well, which is a significant cost. We can compress this entire design to have a much more compact installation. That's going to be a huge amount of savings on the installation phase as well. Again, let's imagine the inlet of a desalination plant. So typically the line sizes here are massive. Let's take Gold Coast as an example, where the line size is around 1.6 meters. So we're going to need quite a significant number of inlet and outlet runs there in order to comply with the 5DN and 2DN. As with the MBBR, why don't we can now with the 0DN compress this entire installation. So not only this huge structure going over the top, obviously the pipework, concrete pad, the support structures, just like I showed you with the MBBR. So some pretty massive savings, massive capex savings, and for only a minimal cost on top of the flow meter, on top of your standard flow meter. Another really nice application example, which we've seen in Queensland as well, is installation on these pump booster sets. So normally you'd have these 5DN on the inlet and 2 on the outlet. Now with the 0DN, we can bolt this flow meter straight onto here, either on the inlet or on the suction side. So we can really compress that entire installation too. Here's a really cool example from the US. So this is on the outlet of a large treatment plant. They have supplied their 1.8 meter, so a DN1800 0DN flow meter. So normally we require 12.6 meters of straight pipe. Now we need way less than that with the 0DN. So some pretty substantial savings there, and also a cool picture here of a huge mag. Here's another one local to Australia. So in this case, we've installed the flow meter, bolted it on straight after this binary flow control valve here. So a nice application for the 0DN. We don't need a big inlet and outlet runs here as well. And there's also a constriction here in the piping. With the 0DN, we can easily overcome that. Here's a nice one from our colleagues in the US. So this is I think it's a DN100 flow meter installed on a waste activated sludge line. Look at this installation. We've got a constriction here, we've got an expansion here, we've got another constriction here, we've got a valve up here, another expansion. For your standard flow meter, it would be a pretty horrible install. The velocity profile would probably be quite difficult to model, let alone install a normal flow meter. So we've installed the 0DN here and it's working really well. Now I'm going to hand over to Taylor. Taylor, you there?
Yes, I am. Thanks, Luke. That's been really informative so far. I'm just going to touch on some of the applications that you might be able to use this device in mining, oil and gas, and also some power and energy applications. So first of all, in mining, there's heaps of different applications you could use this in, whether it's in filtration or flotation processes, whether it's in what Luke touched on earlier around utility water filters for inlet outlet applications. It can also provide improved performance of pipes with poor conditions such as build-up or deposits from hard water. And that also leads into the next application, which is the cooling water management. Another application that can be used is for dewatering skids. So for example, it's more cost effective to utilize this device in dewatering skids than to use flow conditioners or additional pipe lengths. So that's a big cost saving on your project. And for example, if you have mismatched IDs in polyurethane lines out in the open cut pit or even underground, mismatch IDs of up to even 12.5% will give accuracy better than less than 0.5%. So it's really good performance that this device has. In summary, for mining applications for the whole DN range, the Promag W0 DN full bore would work way better than any other full bore device on the market. In oil and gas, similar applications, so whether it's on a separator outlet to reduce the footprint of the separator there, cooling water management, and also production or exploitation skids with water, you can use it on there to minimize the footprint and minimize your project costs too. And for power and energy applications, similar things as well. So whether it's boiler feed water measurement, where you might have some hardness of the water depositing scale on the lines, cooling water management, and also the intake of water for your power generation station. On the next slide, you'll see some photos around one of the applications I spoke about mining, so dewatering lines. So as I mentioned before, the 0DN will minimize any error that's induced due to the turbulent flow that is created by lines that have curves in them or across topography that is not flat, as well as mismatch IDs. In the middle there's a good example of where poor quality water that provides or creates buildup on lines and then creates flow disturbances. Then that's a good example there on the processing plant. And then on the right hand side there, you see an application where the Promag W0DN is right next to a butterfly valve. So you can have an isolation valve that is either on or off immediately before the Promag W0DN, and you can minimize your cost of your projects that way. Okay, so that's the examples for mining, oil and gas. I'll hand over to Gus and he'll speak about the food and beverage examples.
Okay, thanks Taylor for the great explanation. So the main applications in the food and beverage for the Promag W0DN are mostly in utilities, especially in compact installations such as kits for filtration, microfiltration, and even chemical dosing, where space is really a problem. You can see some of these installations in the pictures on the slides. But there's one thing that really, let's say, outstands with the Promag W0DN is that it's an amazing solution, not only from an engineering point of view, but also from the maintenance, from a maintenance one. So you don't need to worry about installing your flow meter, for example, in very difficult areas such as 3 or 5 meters above the ground. Just respect installation guidelines. This can be easily installed in an accessible position to allow you to save time and resources while you're doing the verification and the maintenance of your devices. So it's a very refined solution for the complete product life cycle. Okay, and we already have a very interesting success story here in Australia, where a customer is using the Promag W0DN to monitor the water consumption of a spray chilling process. Okay, so it's an abattoir, and you can see from the picture there are several factors that are influencing the flow profile and causing these disturbances. So we can see there's an inline filter, there is an insertion device just before the flow meter. There are mismatched flanges. So this is really the worst condition for a regular electromagnetic flow meter, but for the Promag W0DN, we can see a very consistent and accurate measurement regardless of the installation conditions. So this is a very interesting case study, and the customer is really, really happy about it. Luke, I think you can hand it back to you.
Awesome. Thanks, Gus. Thanks, Taylor. We'll bring you guys back in, I think, for the questions at the end. Okay, so that's everything we have in the zero to end. So you've seen how it works. You've seen some application use cases. You've seen some real examples from here in Australia as well as overseas. And hopefully you've seen the real benefits of this flow meter and how it can save you on initial installation costs, on CapEx, all those kind of benefits as well. So now we've got a little bit of time to talk about heartbeat self-verification. So with the 0DM flow meter, which we have available in the 300, 400, and 500 series transmitters, we do also have heartbeat self-verification. Now, typically flow meters do require verification, particularly custody transfer or billing flow meters. Now, before we talk about how heartbeat self-verification works, I'm just going to share with you the Mentimeter screen again, and I've just got a question I'd like to ask. So you should see the Mentimeter screen again. Here is the question I've got. So how often are you typically required to verify your flow meters? So those of you who are already logged on your phone or have gone onto the website with the code 279849, it'd be great if you could ask that question. I'm just going to give you 30, 40 seconds to go through that. Okay, getting some good answers here. The majority of you are saying once per year, which has been my experience here in Queensland. Let's wait a little bit longer. Perfect. Okay. So nearly just over half of you have said once per year for flow meter verification. It normally depends on which industry you're from. For water and wastewater, for billing type flow meters, it can be anywhere from 12 months to 24 months. In the life science industries or the pharmaceuticals or the food and bev industries, it can be a little bit lower than that, and say 6 months. And some of you have also put never as well, which we can also see too. So I'm just going to explain to you heartbeat self-verification. 1 second. Switching back to the main screen. So for any of you who've seen our previous webinar on heartbeat technology, we did one on liquid analysis, I think in around April time. You'd know that really there are 3 pillars to heartbeat technology. So the first being diagnostics, that's permanent process and device diagnostics, which we have in the vast majority of our devices, and they are supplied as standard. The second being heartbeat verification. So this is documented in situ, fully traceable verification. We can do that with heartbeat. And the third being heartbeat monitoring. So really a consistent condition assessment of your flow meter or another type of instrument, and the use case for that being for predictive type maintenance. So for any of you in the water industry who've probably mentioned your flow meters needs to be verified once every year, you'd be aware that a typical verification would involve a service technician, either from E&H or another supplier or another service supplier, coming onto site and bringing out what we have is a field check unit. Other suppliers have similar units, opening up the flow meters, connecting up some cables, simulating some voltages and seeing what the flow meter gives back. And then at the end of that, you'll get a verification report, and that's a verification. That can take 45, 60 minutes. It's quite cumbersome. You have to take out the box, you undo the cables. With heartbeat verification, we've built all of that capability into the flow meter itself. So you don't need this simulation box anymore. You can just go into the flow meter on wireless LAN or on the web server or through your DCS and run a verification and be finished in 5 minutes. So a massive time saving there. And the beauty of this verification is that it's fully traceable. So we trace this back to TUV standards. So that means it's good enough, or it's exactly the same as an external verification. We verify up to 94% of the meter. So the inlet output module, the sensor electronics, the sensor itself, and then we give you this traceable report at the end. So from having 45 minutes of verification where the costs of a service technician to travel and verify the flow meter now to you being able to do it in 5 minutes, either over wireless LAN or the web server or the DCS. So there's a massive cost saving for this. And the verification reports are great. As I mentioned, they're fully traceable. You have a completely reported verification where you can put back in your archives. The standard verification has 2 pages. The advanced verification has 3 pages. We look at all of those different checks and we can sign it, or you can sign it at the end. And there's your verification report for that flow meter at that time. So very, very useful. And we will hopefully in the next few weeks be sending out an email with a return on investment calculator for heartbeat verification too. So that almost brings us to the end of the presentation. You'll have copy of these slides in an email tomorrow. You can also download them on the dashboard on the side. There's plenty more information on our website. There's a nice video demonstration of the 0DN, and you can also perform any sizings you like via our applicator tool online. So with that, I'm going to bring Taylor and Gustavo back in. And we're going to get through some questions. Guys, we've got roughly 10 minutes for questions. So fire away, Taylor.
No worries. Yeah, so we've got lots of questions coming in now, which is really good. If you still haven't asked any questions, then make sure you're typing it in the panel on the right-hand side, and we'll answer them now. A good question has just come in, Luke, for you. Sean asks, what has the uptake been like with clients? So, for example, he knows that with some clients, they don't like to jump on new products as they come out. Probably from your experience, how much has the engagement been in your industry there?
Yeah, no, it's a great question from Sean. Typically, a lot will like to follow, and few will like to take that very first step in introducing this technology. We found the uptake in Australia to be some of the best worldwide. So we, at the moment, we supplied just over 30 of these 0DNs. We've had inquiries for plenty more of these flow meters for a wide range of application, from your standard 100, 150 mil applications in, say, sewage or water pump stations, all the way up to 1.6 flow meters for a large water distribution network. So yeah, we've managed to supply quite a few of these flow meters. Our colleagues over in the US have done very, very well in the first few months of this release. And we're expecting that number to climb quite significantly, I would say, in Q3 and Q4 this year too.
All right, we do have another question from Dominic. So what is the accuracy like at low flows or velocities?
Yep, good question. Dominic, I displayed that third-party testing towards the start of the presentation. So we found that the accuracy of these flow meters, particularly after bends, is very, very good, around 0.2, 0.3% error. There is an applicator tool, which I've mentioned before, and you'll get the link to it when we send the email tomorrow, where you can input your complete flow range, and then you can print out an accuracy graph to see exactly where you're sitting as well, whether at low velocity, at high velocity. But we found that over a standard flow meter, we are quite a bit more accurate. In the 0DN applications, we're well within that 0.5%, even at those low velocities. And I'm happy to send you that calibration, that third-party certificate as well, Dominic, and you can see for yourself.
Awesome. Dominic says, thanks, Luke. I've got another question from Lisa. She asks, can you elaborate on the additional equipment that's needed to calculate a monthly flow in cubic meters through the pipe, like, for example, a data logger, and can this be monitored remotely?
Yeah, so we did have quite a few questions before the webinar. So there was an option when you registered to ask your questions for myself, Taylor, and Gustavo. And probably 60% of those questions were related to remote connectivity, so IoT type connectivity, which we know is huge in Australia, particularly since our water networks are so well distributed. I can say for that, but we do have all the digital comm platforms available. So you can, for example, use Modbus, connect into an RTU, send that data remotely and into either your dashboard or our own dashboard as well. So those options are for sure they're easily available. And later on this year, we will be bringing out another option as well, which has really true remote connectivity with the 0dm flow meter. So stay tuned for that one.
All right. We do have another question from Amjad, and he says that installing on a existing pipe system may be costly because they need to cut the pipe. Is there any other way to measure flow without cutting the pipe?
Yeah, I mean, if you do have a pre-existing line and we'd like to measure flow in, and you wanted an inline flow meter, like an electromagnetic flow meter, you don't really have much choice. You are going to have to cut the pipe. But the beauty of the 0dn is you won't have to cut the pipe and put in a bend, put 5 diameters upstream, 2 diameters downstream, put another bend, put that back into your process. The cost for that, depending on the line size, are going to be quite high. So that's the real advantage of the 0dn. You can cut the pipe and drop it straight in. If you don't want to cut the pipe, for whatever reason, you can install, say, for example, clamp-on ultrasonic. But with those flow meters, we do need a significant number of upstream and downstream lengths. So I think from memory, it's over 10 or 15 upstream and 5 downstream. So those are your two choices. I mean, don't cut the pipe, put an ultrasonic in and maybe have some inaccuracy if you don't have those upstream and downstream lengths, or you cut the pipe and you drop the 0dn straight in there without any issues.
Thanks, Luke. We've got another question now, which I'm sure a lot of people are thinking. Sean asks, what is the cost difference like with your other mag flow meters? Are the 0dns cheaper or more expensive?
Yeah, so Sean, like I mentioned on the slide towards the end of all the details about the 0dn before we got into the application examples, but the cost of a 0dn over a standard flow meter is only 5% more. So if we spec up a DM150 Promag W400, which let's say 4 to 20 output, table D flanges, compact transmitter, and then you have a certain price for that, and then instead you wanted the 0dn, it's only 5% on top of that price. So it's priced very competitively, particularly for the water and wastewater market.
Good. We do have another question from Jay Empathy. What is the reasonable life expectancy of these flow meters before replacement?
Yeah, it's a good question. I mean, look, it depends on the application. We've got mags installed in Germany that have been there for 25 years. Standard flow meters there. If you want a nice, clean, potable water application, they can last for a number of years. I mean, if you do have corrosive applications and you haven't specified the right electrodes, then they're not going to last as long. But look, there's no real improvement on the 0dn with a standard flow meter. It really depends upon your application. So look, if you do have a specific application, feel free to scan that QR code in, which you can see on the presentation slide, send me an email, and I can give you some similar examples.
Awesome. We've got one more question. Luke, we know you spoke about heartbeat verification. So there's a question from Vania Singham. Asks, what is the ongoing costs of maintaining the software associated with the flow meter verification?
Yeah, so a standard heartbeat is supplied with all of our latest series flow meters, the Proline 3s, the 300, 400, 500, and some other transmitters as well. It's up to you to unlock it, or it's your choice to unlock it. Once you unlock it, there's a certain cost for that, and then it's yours for life. There's no upgrade costs or update costs every year. Once you get self-verification, you have it for the entire lifetime of the flow meter. So that's a pretty nice advantage of having that self-verification feature.
Very good. We do have another question. Does the flow meter detect cavitation bubbles?
Taylor, this one's more for the mining industry. Look, mag flow meters can't detect cavitation, as far as I know. I think there are some other types of flow meters where there is the possibility to detect that. Taylor, do you want to expand on it?
Yeah, so electromagnetic flow meters can't detect cavitation, but If we do want to detect and train dare, the Promag Q, which is a Coriolis mass meter, would be up to do it. So that's an option. And there's a few others as well. But if you've got specific process details, then you can just send them through and we'll have a look and then we'll get back to you.
Cool.
In terms of questions, I think that's it. And we're just bang on the money there for the time. So Luke, would you like to do a quick conclusion?
Yeah, brilliant. Thanks everybody for your great questions. Thanks for attending the webinar. Thank you to Gus and Taylor for your application examples in your industries as well. There is a QR code there, guys and girls. If you scan that into your phone, you'll find my contact details. Feel free to send me any questions directly. And once I end this webinar, there'll be a short survey. It'd be great if you could answer that as well. And where there's also an option to ask questions. So apart from that, thanks everybody. Have a great afternoon, morning, evening, wherever you are, and we'll see you all soon.
All right. Thanks, everyone.
Thanks, everyone.
See ya.
See you guys.
See ya.